Okay, hey, this is Mr. Ashi, just trying to show you that sometimes, even though you might want to write an equation in slope-intercept form, that it might be easier to first write the equation in point-slope form and then change it to slope-intercept form. So for the example that I have here, you're given a line that passes through a point, and then the slope is 4. So we have two things. We have a point, and we have the slope. We want to write the equation in slope-intercept form, but we don't have the y-intercept. Since we do have a point and the slope, again, it might be easier to first write the equation in point-slope form, and that's what I'm going to do. So in point-slope form, remember point-slope form is y minus y sub 1. That's equal to m, the slope, times the quantity x minus x sub 1. So this point right here, I could label that as x sub 1, y sub 1. And then the slope is m. So I could plug those numbers into this equation for point-slope form. Y minus y sub 1, that'd be y minus 1 equals m, which is 4. And then times the quantity x minus x sub 1. And then x sub 1 is negative 2. So it'd be x minus negative 2, which means that's x plus 2. So this is point-slope form, but I'm going to change it to slope-intercept form. If you remember, slope-intercept form, first of all, is y equals mx plus b, but it's solved for y. So I want to solve this equation for y. And then if you ever want to change an equation from point-slope form to slope-intercept form, you do kind of the same things each time. Here's what I mean by that. I want to distribute the slope on the right-hand side. So on the left side, it's just y minus 1. On the right side, it's 4 times x, which is 4x. And then 4 times 2, which is 8. And then we only need to do one more thing to solve this for y. And if it's solved for y, then it would be in slope-intercept form. So then I could add 1 to each side. You could only add 1 to the 8 on the right side. Then the equation becomes y equals 4x. 8 plus 1 is 9, plus 9. So again, here's what happened. We started with an equation in point-slope form because we were given a point and the slope. So if you have those two things, then it should be easier to write your equation in point-slope form and then change it to slope-intercept form. I'll go over another example in a second here. Okay, so for my next example, I basically want to do the same thing. I want to write an equation in slope-intercept form that passes through the point 2, negative 5, and then the slope is 1/2. So since we're given a point and the slope, it's probably easier to write the equation first in point-slope form. So point-slope form is y minus y sub 1. I'm going to label this x sub 1, y sub 1, and then this is m. So y minus y sub 1 would be y minus negative 5. That's the same as y plus 5. And then that's equal to m, which is 1/2, times the quantity x minus x sub 1. So x sub 1 in this case is 2. But then I want to change this into slope-intercept form, which means we need to solve it for y. So like the previous example, I first distribute the slope. In this case, the slope is 1/2. So on the right side, 1/2 times x is 1/2 x. 1/2 times negative 2. A positive times a negative is a negative, and then 1/2 times 2 is 1. And to completely solve this for y, we need to get rid of the plus 5, so we could subtract 5 from each side. We only subtract 5 from the negative 1 because those are like terms, and it's y equals 1/2 x, and then negative 1 minus 5 is negative 6. So we started with our equation in point-slope form right here, and then change it to slope-intercept form. For all of those two examples, then you should be able to take any equation in point-slope form and then change it to slope-intercept form in a similar manner.